friends, welcome back. We're here to talk today about angle side congruency. So this means if we have two triangles that look like this, let's see, we gotta get those guys. If we have two triangles and I say this angle and this angle are congruent to this angle and this angle, and then I have a side that is not in between those two angles, so either this side or the other side, if I say that those are congruent, then I can declare these triangles are congruent based on angle, angle, side. Okay, so let's talk about a proof with that. So here is our information. And in a previous video, I mentioned my little cheat sheet for how we can kind of a checklist of things to make sure that we're including the right things on our proof, right? So let's take a look. We're going to check out our givens first and list those. But when we do our givens, you want to make sure that you're marking them as well. So like AD is parallel to CE. And then BD is congruent to BC. There. All right, cool. So now that we know that, we can put our givens, right? And so let's list our givens there. Now with that information, let's see what we can do next. We can say any definitions. Well, I don't see any definitions that I need, like midpoint or anything like that. So let's look at our obvious but not givens. And I see a couple that we have here. Because we know this line is parallel, or these two lines are parallel, and they are cut by a transversal here. This angle and this angle are congruent. This angle is also congruent with this angle because DC is also a transversal. So what we have here is the so for number 2, what we would say here is, okay, angle DAB, that's that 1-1, angle DAB is congruent to CEB. Also, angle ADB is going to be congruent to, and let me sketch this up just a little bit, so that's ADB is going to be congruent to ECB. And as I mentioned before, this is because alternate interior angles are congruent. I can't spell and talk at the same time. My goodness. Okay, so alternate interior angles are congruent. So we've done our definitions are obvious but not givens. I see another one here, which is our vertical angles, but we don't really need that because we have these other two angles that work. So at this point, I have angle, angle, and then a side in these triangles. So what I can say is these guys are, so triangle ABD is congruent to triangle EBC. And we have to be very careful about our congruency statement there. So we said ABD. So I went from the little 1- to the no dash to the 2-. EBC, the 1- to the no dash to the 2- in my little angles. That's how I think of it. So for 3, we've got angle, angle, side, and there we go. We have declared this guy is congruent. So excellent work. All right, folks, I had to gather my other one there. Let's try another one that we're going to do. All right, we're given that RPQ and RTS are congruent. Angles RPQ and RTS are congruent, and R is the midpoint of QS. So RPQ, that's this angle right in here, and RTS, that's this angle right in here. Those guys are congruent. And then we also know R is the midpoint of QS. The midpoint means that it creates two equal halves. So first things first, we're going to write down our given. Now what we're going to do in our little checklist, again, we have definitions, right? So the definition of a midpoint is it creates two equal halves. And the way we would write that mathematically is QR equals SR. So because I'm going from the outside in. So QR is congruent to, I think I said equals, and I'm sorry, I didn't mean to say that, SR. And that is because of the definition of a midpoint. The very definition of a midpoint says that it creates two equal halves. So def of midpoint. Okay, after that, I do my obvious but not givens. And those are things like reflexive property and vertical angles. And I see a vertical angle here. If you look, we see that PRQ So PRQ, that's this guy right here. And then TRS, so angle PRQ is congruent to angle TRS. And that is because vertical angles are congruent. Vertical angles are congruent. So now looking at these triangles, and sometimes it helps if you cover up, oh, whoops, I should mark this other one. So sometimes it helps if you like kind of cover up one of the triangles if you need to. If I were to cover this up, you see that I have angle, angle, side. The side is not in between the two angles, so it's not angle, side, angle. It is angle, angle, side. So we can declare these guys are congruent. PQR is congruent to triangle TSR, and keep an eye on your congruency statement. Make sure that matches up, because angle, angle, side, because of angle, angle, side. All right, folks, excellent work. We'll see you next time.